so we made sure we imported in. We went to the input. We made sure we have our program open before we do anything else. We got to make sure we have an NC program. Okay, that's the first thing we do when we open up the lathe. We either make sure we're on an NC program or the file that we want to open. So I opened up my drilling intro file. Then I went to my input screen and import export functions. And I'm going to import my NC state from file. There's my file right there in my CNC lathe lessons. I'll hit load selected and tell it to begin operation here. Okay. That says it's been restored successfully. All right. Okay. Then I'll check and make sure all my tools are there. And then after I check the tools, I want to check and make sure my work offsets are there. So I got to have that 10-inch 50 thou. Now, our NC state, we only have it saved with the G54, but we're using G56 in this program. So you got to be aware of that I have to come in here to get it to draw correctly. I've got to come in here and plug in the same work offset value, 10-inch 50 thou, in the G56 to get it to draw. Then the second thing I have to do in here is go to stock geometry and tell it the correct outer diameter. That's what your numbers should come in as by default. So that if yours doesn't have that 10-inch 50 and the 50 thou over there, put those in, because we're going to resave your NC state. The only thing you should ever have to change in here after loading your NC state is the stock diameter. So for this part that we're working on is 1 inch and 5/8. So we got to change that stock diameter. Okay. Did anybody's not have the stock length and that stuff there? Is everybody's good there? It should have saved with your NC state. Yeah. You should be able to just type in the Z and it'll automatically pull that in. Just type in the 50 thou for the Z. Did it not have it by default? Okay. So if yours didn't have these numbers here, this 10-inch 50 thou, this number here, and even over here in part setup, if you want to, what I would do is you could go through here and put 10-inch 50 in all of these Z offsets, and make sure you put 10-inch 50, not 10.5 inches. Yesterday I had multiple people put 10.5 inches. That's 450 thou further over, and then it was cutting air out here. So if you wanted to put that in for the first 6 offsets, and that way it automatically will save that with your NC state, it'll keep you from having to do that again in here in the classroom and on the computer.
So now whenever we save, that'll be saved to that NC state.
Yeah. So now once we've typed those in, if we go back to the input screen and import export functions, this time we'll save our NC state. I'm just going to click on my NC state file and let it save over it. It's going to pop up. I'm going to tell it yes to override it. Now that'll save all those work offset values so you don't have to go in and put those in. But you need to be aware of it. You definitely need to be aware of that. Anytime you see a position off, something's not lining up where it was before, it's probably a work offset problem. It's a setup problem. Okay. Is everybody's drawing okay now? Everybody's not drawing. Draw. So right here, watch what happens when I take this space out right here. See how that S popped back up over there? Go ahead and just go over the program manager and save that. I saw that yesterday a couple times. Something I had happening yesterday, and a couple people had this, in the syntax lines, meaning the start and end markers. So up here, I put the % sign and that's it. There cannot be a space. Watch the S. Whenever I hit a space bar here, watch the S. See how it just disappeared? It just moved my start marker down here to the bottom % sign. that space cannot be in there. Okay, they got to make sure that that start marker, the S over there on the left-hand bar, is there, because what that does is, this is what was happening on Rachel's. It basically says, okay, I'm going to run the program, everything from here to here, and when she hits play, nothing was happening. That's because the start and end markers were messed up because I had hit the space bar in there. I saw a couple people yesterday that had that happen. So we got to make sure we don't put a space after the percent sign. Okay, and then as long as that start marker's there, you should be good and it should draw now. Everybody's drawing? That was it drawn where you good the other day? Where you left? okay? Roughing okay? All right. So we've got them roughed. We'll go ahead here and we're gonna move back to our boundary point. So I'm gonna come up here and copy the move to boundary again. Remember, at the end of every sequence, we always want to move back to that boundary point. Okay. All right. What we're going to do now is we're going to go ahead and center drill and drill this part. And then we're going to come back in with tool 2 to finish the profile. Okay. So we're back at our boundary point, but we got to do a tool change. So we have to basically get the turret out away from the part, and I always just send it home. I don't just, sometimes if I'm in like a production situation, I might just send it out of the way in X to get it back away from the part. But most of the time, in just a normal circumstance, onesie, twosie thing, I'm going to send it all the way back to the corner. That way I'm plenty far, because I'm getting ready to bring a drill into the situation. That drill is going to be sticking out further than what the turning tool is. Yeah.
Why not go ahead and finish it and then drill it? Why drill and finish?
You can do it either way. I just wanted to go this route.
Alright.
Yeah.
I didn't know if there was.
No, sometimes I'll drill it. Trying to think of how to explain that. A lot of times I'll want to get all the other operations done before I'll come in and do that fine finish pass. I think it's more personal preference probably than actual situational, preference. But I'm just going to go ahead and get that center drilled and everything, and then show you that we can come back in at the end. And a lot of this is, for example, I want to show you that we can still at the very end, after we've done all the drilling, we're still going to be able to call in those sequence numbers from way down below rather than right after. So, all right, so we'll go ahead and do our G28 U0 to send it home in X. Excuse me. I'll shut off coolant. Then I'll do a G28 W0 to send it home in Z. I tell it that we're going to center drill for drilled hole. Our center drill is tool 6. So we're going to do a T0606. And I'm actually going to come up here to my last tool change and basically make sure I kind of model right off this. We're going to copy our T6 comment up here. Put that right under our T606, and then we'll put our M1 with a verified tool. We're going to verify that the center drill is now in the active position. On the lathe and the mill, the tool number doesn't necessarily have to match up to the pocket on the mill or the carousel number on the lathe. Tool 1 could be in station 10. It could be in station 6. It could be in station 7. And a lot of times on the lathe, you're going to put them wherever you need to put them to have correct clearance. Meaning that two tools that are, if I've got a turning tool, I'm probably going to have a drill right next to it, because if I do that, when the turning tool comes in, it's turning the part, with the drill right next to it, the drill is going to start hitting my chuck. So a lot of times you got to kind of index and space them out and put them wherever they need to be so that you have proper clearances. The mill, for efficiency, when it does tool changes, whatever the next pocket available is, it sticks the tool in whatever that pocket is. So 24 pockets on that carousel, the tools could be randomly put in all those. The machine keeps track of where they're at. So it knows tool 1's in pocket 17, tool 2 might be in pocket 5, tool 3 might be in pocket 6. And then what it does is, in the program, with the side mount carousel like that, we actually will tell it, we'll do our tool change, come down, and then we'll have another T value. Like if I'm getting ready, I'm running tool 1, and then a few lines under that, I might put a T2 in that line without an M6. And what that'll do on the mill is it will go ahead and index the carousel and pre-stage that tool. So it's down and ready, so whenever it's time for a tool change, that tool drops, it grabs the one out of the spindle, grabs that tool, arm drops down, swaps tools, and puts the tool you want back in the carousel. So That's something you can do on the mill. So you'll see us doing that too. And our master cam, our post, it automatically does it. It automatically has that built into our post to where it pre-stages the tool. Saves time on tool changes. Okay, verify tool. I'm going to go up here and I'm going to borrow. I'm going to copy everything from my G97 down to the G95 right here. So I'm going to copy all of that. I'm going to paste that in. Now, a couple things. When we're drilling, is the RPM going to change or vary? No, it's going to stay set at whatever the RPM is. So in this case, the G92 and the G96 are not needed. I can get rid of those. And I can just tell it, hey, G97 S1000 M3. And then we'll set it to 1000 RPMs and it won't change. Okay. We are going to do feet per rev. We're going to give it its speed per rev of 2 thou here in a second. And now we're going to move to the drill point. So what I do is this. I move first, I'll move over in X or Z, and then I'll move down in X. So what we're going to do is we're going to come to what we're going to call our initial height. Okay. So we're going to do a G56, G0, and we'll go to Z 1 inch. Call that our initial height for drilling. You got to basically think of, take your mill, your Z, turn it on its side. That's our initial height. Then we'll come down to the center of the part. We'll come down to X0. Move to part center. This typically is the freak out move, and that's why I stay 1 inch on onesie twosie parts. I make my clearance height or my retract height 1 inch, because when this drill is coming down, and think of it like this, and this is my part, as it's coming down visually, if I'm over here like 100 thou off, it's going to look like it's going to hit. Okay, and you get a little freaked out. But if I've got it 1 inch out, I can visually see that I'm good there. And then when it gets right here, I can even pause for a second and make sure that that distance between the part and the drill is 1 inch. Okay, and it helps me verify that things are set correctly. All right. Okay. Next thing we're going to do is our drill line. So we're going to do a G82 cycle. We're going to spot face counterbore with the center drill. We're going to tell it, hey, just go back to that initial point, G98. And we got to tell it a depth to go to. Okay, the depth is a calculation. Give me 2 seconds here. I'll open up the formula sheet for you. Okay, so we've got a number 4 center drill. I want to calculate my point depth based on what I want my desired diameter to be left behind. So when you center drill, a lot of times, you know, you go out there, tip, and then when you get on the bigger diameter, you go about half, you know, or whatever you think you need to go. It's just kind of a visual thing out there. In here, we're going to calculate it a little more so that maybe we can leave a chamfer behind and don't have to come back in to put a chamfer on our hole. So for this one, what we would do is, let's say I want 270, 10 thou per side chamfer. Okay, now yeah, it's a 60-degree chamfer, but it's still a chamfer. So I'm going to say I want 270. So I type 0.27 minus the tip diameter, which was an 1/8 inch on a number 4 center drill. Oh man, there's just not quite enough room. There we go. Okay. Minus the tip diameter, that gives me 145. I take that times 0.866. That gives me 125.57. Plus the tip length, which is an 1/8 inch as well. So basically I'm going to go 250.5 thou deep. So that's what I'm going to plug in for my Z there. Minus 0.2505. We'll see how that looks here in just a second. Pretty sure WinMax has all the center drill parameters all stored in the background. So, all right, we need an R plane, a feed plane. Well, I'm gonna make that like 100 thou. That way, it's not feeding from 1 inch out. It's gonna come to 100 thou off the part and then feed from there at a feed rate of 2 thou per rev. So unlike the mill where we've got multiple holes, there's always just going to be one hole on a regular 2-axis slant bed lathe. You're just drilling in the center of the part. So after that, we literally do a G80, G0. I usually wrap it back out to the 1 inch and shut off my coolant. And then I'll do my G28, U0, G28, W0. And that's what the drill cycle on the lathe looks like. The can cycle, no different than the mill, other than we're feed per revolution, not feed per minute like on the mill. Obviously, there's no other positions. Now, I do believe, hold on a second. I think I might have lied to you. I think it's going to throw an alarm. Nope, it didn't. Well, we'll see what it does when it gets to the drill. Oh, it's okay. Okay, never mind. So I was worried they might have updated it in this version of the software. Basically, it used to make you put the X0 in this line as well, because our post did that, but I bet they've updated the software because I brought it to their attention, so it must not do it anymore. What it would do is it'd say, you have to have an incremental X distance for your drill point. So all you had to do was you had to add your X0 into this line to make it do that. So if you ever see that, if you get on an older machine and you see that, it's just asking you to tell it, hey, X0 is where I need to be here. But this one's doing just fine. Hit save. And we've drilled our part. Okay, now we're ready to, or we spot drilled or center drilled our part. Now we're ready to drill the part. So, I'm going to keep it pretty simple here. I'm going to put me a comment. My pec drill, the 1/4 inch hole. And just like what I would do on the mill, after I've spot drilled on the mill, we copied this tap drill cycle. We made our changes. We copied the tapping that cycle, made our changes for tapping. I'm going to take everything from the T06 up here down to the G28W 0. I'm going to take that whole center drill cycle and copy it. And I'm going to put it down here to be modified. We're going to bring in tool 7, so T077. Go up here and get my tool 7 comment. Bring that down and paste it over the tool 6 one here. My drilling, make sure you go down far enough till you're down here. No, don't mess this one up. Once I've got that, I can tell we're going to go 1200 on the RPM. Then down here in the drill cycle, all this stuff's good. We'll come to the drill cycle, tell it we're going to do a G83. We need 0.75 straight wall. Okay, no problem. 0.25 times 0.3 gives me my tip length, 75 thou. So I need 0.75 plus the 75 thou. I got to go 825 deep with the drill tip. And then the only other thing I'm going to add to that line, since we're peck drilling, I got to tell it how much I want it to peck, which is a Q value. And let's just peck 125 per peck. We'll go half the drill diameter. And there you can see we left this a chamfer behind, probably a little bigger than what's supposed to be. The tip geometry is probably a little bit off in WinMax, but that formula should work in reality. If I shut off my shading here, and you can kind of see that. So what I just did, I went into my settings on the lathe. Sometimes if I've got internal features, I'll turn it on half view right here for the section view. Make sure your ZX is your default view, or XZ. And that way I can kind of see what's happening there. And now it does, it splits the part in half there. You can kind of see what's happening. But I can see how that's working out for me. Everybody's drill okay? If it looks good, go save it. If it doesn't, get your hand up. Everybody's good? All right, cool. All right, next, now we'll go back and we'll finish that OD, and then we'll part this off. So we're going to go ahead and we're going to say that we're going to finish OD profile. I'm going to go up to the tool 1 tool change. I'm going to take everything from the T01 down to the M8 right here. And yeah, I've got to modify a few things, but for the most part, it's going to be pretty good shape there. So I'm going to copy that. Come down to the bottom and paste it in and tell it we're going to go to tool 2, T0202. Go up here and get the comment for tool 2. Paste it over this one. We're going to verify the tool just the same. Move into the same boundary point for the start of the finished profile. Turn on the spindle at 500 RPM, max RPM of 1200. I'm good with that. I got to change my CSS to 1230 for this tool. And we're going to do feed per rev. So I changed the tool number, offset number, the comment, and the CSS, constant surface speed, for that tool. And now we'll do the finish pass. So this is kind of why I'm jumping out of order. I wanted you to see this because it's still the same. I know the profile I want is the same profile that I did up top roughing. So I come up here and I look in my roughing all the way back up here, I used P3, Q4. That's what I want to finish. So down here, I'm going to put P3, Q4 with my feed rate of 3 thou 7/10. And then after I do that into sequence there, I'll move back to the boundary point. And you should be able to draw that, and you'll see it'll come in and center drill and everything, then come right back in. It's going to look back for those sequences, those sequence numbers, and finish it out at the end. So those sequence numbers, that's why you can't use the same numbers twice, regardless of what order you're in, because it goes to the top of the program and starts looking for the N3, N4, or N1, N2, or N5, N6. It's looking for those through the whole program, and whenever it finds the first one, that's the one it's going to want to use. So if you try to repeat those numbers, it's going to grab the first one every time. Okay. So let's do a part off. So you can see how when you're manually parting or grooving, there's not really a can cycle here, it's just a movement. We're just going to move with it. So we'll do our G28 U0 M9, send the spindle home, and G28 W0 for a tool change. And we'll tell it that we are going to part off workpiece. Okay. Now I don't believe we didn't put that tool up here in our list, did we? All right, let's look and see what number our parting tool is. Tool 4. So I'm going to put that right here. I'm going to put T4 part/groove, and then I'll go get my constant surface speed and IPR out of my tool library. So we calculated at 46 for the CSS and 2 thou and 4/10 for the part off. For the tool change, once again, I'm just going to use the T1 here. I'm going to copy all of this. So everybody get that comment in there okay? Take a second, if you need to, go and put that in. Once you got that in there, I'm going to copy the tool change lines here all the way down to here. Copy that again. And I'll come down here and paste that in. I'll modify it, tell it we're bringing in tool 4. Tool 4, offset 4. Copy my tool 4 comment. Okay. Now, right here, the boundary point. We're not really doing the boundary point here. We're going to move back to the back of the part to part it off. So, our Z here, we're still going to go to X 1.675 off the diameter. That'd be fine. But our Z, we need to go back to Z minus 2.118. The length of the part, the finished length of the part, plus the width of the parting tool. Okay, so that's going to change right there. The CSS, the constant surface speed, we're going to set that to 46. That's that parting tool's slower feed rate. Okay. And that's basically all we got to change with all of that. Now sometimes, depending on what I'm doing, my max RPM, I might slow that down. If I go to part this off and it's chattering, you know, even at 46 for the CSS, when it gets down to like 0.375, let's say 46 times 3.82 divided by 0.375, well, it shouldn't be too bad. It shouldn't hit the max RPM. We'll be all right. But there are times where you'll be parting something off where you got to drop your max RPM because you're getting chatter. You know what I mean? You just got to slow it down. So here, this part will probably be okay with that small of a number there. Okay. Next thing we're going to do is we're basically just going to do a linear move to part this off. Now we could do a peck move. So sometimes what I'll do is I'll go in like an 1/8 inch at a time and then dwell and then go another 1/8 inch and dwell and let it break the chip rather than just sending it straight down central home and letting it roll up a great big chip and take the chance at it building up on the edge of my insert. So to do that, it's pretty simple here. We would do a G1 and then the first move, let's do a X 1.45. We're going to move to the part and we'll get to the part. Let's go ahead and let's come down at a feed rate of 10. We'll go 4 times what the IPR is there. Remember, the part's already turned to 1.45. So we're already there. We're just getting it to the part without actually getting into the cut yet. Once we get there now we can look at it and we can say, okay, we're going to part this off. I'm going to do an 1/8 inch at a time and I'm going to do a 1 second dwell in between each 1/8 inch. So if I'm going an 1/8 inch at a time incrementally, and that's what I'm going to do, we're going to use a U. I'm going to do an incremental part off here. So if I'm going to do that, I'm going to say 1.45 and I'm going to come in an 1/8 inch at a time incrementally. So I'm going to tell it, hey, divide this by 0.125. It means I need to do about 11 repeats. Okay, will get me there. 12 technically will get me there. So what I would probably do is I'd probably do this. Let's say 1.45 divided by, divided by 10. We're going to go, let's go 145 at a time so we get a nice round number. Is everybody okay with that? That makes a little more sense to me too. We'll do 145 at a time. So here, we're going to do a U minus 0.145 at a feed rate of 2,4/10. And then we're going to put a G4 with a P1. G4 is a dwell. The P is how long we want it to dwell. If I draw that, you should see just a little cut there. Now, what I'm going to do next is I'm going to copy that. I'm going to repeat it. Now we're doing incremental. So I could do absolute and just do the math with the X value each time. But if I do incremental, now we're into the part. We've cut 145, 145. It should take like 5 times. Remember, it's doing the incremental per side, so it should take 5 repeats. So there's 1, there's 2, there's 3, 4, and 5. watch that, it should part all the way down to the center now. There we go. Now my other option would be to do the math and make absolute X values. So I just subtract 145 and X, or well, 290 technically, because we're taking it 145 per side is what we're doing. And we go incremental. And it should part it off. How's everybody's look? So once I've done that, I want to get this part, I want to get it back out of the way. So the first thing I would do is I would do like an X 1.625 and maybe bump the feed up to like 20 per rev. That way it feeds out. I don't want to rapid while I'm still up against the part. Say a feed out move. And then I would do a G28 U0 M9, G28 W0, and then after that I would put my M30. I'll hit save on this, and that part's complete. We've done that. I wish we could see the dwell. It'd be nice if we could see it spinning and actually dwelling, but that's what's happening. Every time it goes in that 145 thou, it pauses for 1 second, which should be plenty of time for it to make a revolution, break the chip off, and then it goes in another 145. Okay. We could do that absolute too. Like I said, we could do the math. We could come in X amount each absolute value, and we will do that. You know, I'm going to do things, well, it just depends how I feel that particular day, to be honest. But we're going to do things differently whenever I feel like it's time to do this a little bit differently. You're going to get into the consistent era on your own when you start programming on your own, to where you're going to find what works best for you, and that's what you're going to use. But I'm going to try to kind of be diverse about how we do it, because I want you to see that there are 3 or 4 ways most of the time, if not more ways, to get to the same result. Okay, there's a lot of ways to approach it, and especially when we get into the CAM software next year, you know, there's 5 or 6 toolpaths that will give me the same results for certain things, but one of them might be one that I just like better, okay, or that's simpler. All right, sometimes people, like when I have a slot, some people love using the slot toolpath. I prefer, if it's just a slot and it's not too much wider than my tool, I just prefer to use a contour toolpath and do a ramp entry and let the standard little contour toolpath do it, because it's a really simple toolpath and I get the same results. So, but if it's a big slot, you know, then you're probably going to want to use that because you got a lot more roughing to do. So it's all about what the application is for how I decide. Okay. All right. Da-da-da-da-da-da. Looking for my lesson in my book. That's not you. You think you can program that for me? Somehow one of my second year lathe lessons got in with all of yours. Assignment for next week. On Wednesday next week, we're going to do a lathe quiz. We're going to come in here and do some more lathe programming together on Monday. We're going to do a lathe quiz on Wednesday. Okay. What I'd like you to program for me, or start on programming, I guess I should say, is this part right here for the mill. you have until 2 Mondays from now. Okay, so you got all of the rest of this week, all of next week, the following Monday to have this program.
17th.
Is that 17th? Sounds good. Yeah, 17th. 17th to have this part programmed for me. This part's fun because it's got this island here. So you're going to have to do some roughing. You might, honestly, I tell everybody, I just rough it using center line. I wouldn't try to use cutter comp. But you could use cutter comp and you can kind of spiral your way in. You just can't go back and forth like you could if you just do center line and do some math to kind of face off that extra material. What I've always told everybody to do is do the math and kind of just face off the material and make this a square here. And then come in with cutter comp and mill around that, mill out the circle in the center. Okay, you're going to have to do some math in here for these pockets. You're probably going to have to use center line, no cutter comp in these triangular pockets. As if I remember correctly, there is not enough information to get the points without doing some pretty high-end co-radial math to get the tangent points figured out. Most of you, I assume, probably haven't done a lot of that in any math classes up till now, unless you've been in some higher-end geometry classes. And that's stuff we work on next year. So when you come in here, you're probably just going to want to plunge in, come out, center, let the tool form this. Okay, around the outside, use cutter comp. Around this boss, use cutter comp. But these triangular pockets, you don't have to use cutter comp. Okay? Questions? All right, yep, you got till the 17th on that one, so you got something to work on, keep you kind of consistent. Yep.
Yeah, what do you want the stock size to be?
On this, your stock size is going to be the 4.5 by 4.5 by,
That's it.
yep, by 450. Yep. Okay? All right. This one will get you where you need to be for the final. Once you work through this one, and then we go to this one, the final will be a breeze, I promise. You program those two over the next few weeks, the final will be a breeze. All right. Questions? Any others? All right. You got the rest of the time. You got basically 45 minutes, 50 minutes, so you can start working on that.